Hey everybody. If you were not able to learn how to do this algebra homework from the other video with the very similar numbers, I'm here to go over these exact problems for you, and hopefully you will understand it better when we're done. Okay? All right. By the way, you guys work on Saturdays too? Here I am on a Saturday. It's windy out there still. Here we go. Again, the first thing I always tell kids is remember, slow is smooth, smooth is fast. Your goal here is what am I trying to do? Well, on all of these, what you're trying to do is find out what that variable equals. On that first one, I want to know what m equals. On the second one, I want to know what y equals. Right? And on the third one, same thing. Okay, we're looking to see what does that equal when we're doing this problem. Okay? All right, let me get a green pen to solve, or let's try a black pen here. And I will use the red pen just for what? Do you know? When I show the inverse operation and to do the same thing on the other side, right? Which is what this stands for. Do the same thing to the other side. Always, right? You can do anything to one side of the equal sign. As long as you do the same thing to the other, it stays in balance. So here we are. This first problem, I want to eventually, on the bottom here, have m equals a number, right? So if I want the m equals a number, I have to get rid of everything else on that side of the equal sign. So usually what I do is I rewrite it. It doesn't take long. M minus 7 and 28/100 equals 23 and 9/10. And you notice when I do rewrite it, I give myself some space. What am I doing? I'm giving myself some space to do the opposite or inverse operation. Remember, the simple way to remember it is I'm doing the opposite. If you want to sound like you're really smart in math, start realizing that the opposite in math is we call it the inverse operation. What is the inverse operation for subtraction? It's addition. Okay? So if I want to get rid of that minus 7 and 28/100, I do the inverse operation and I add 7 and 28/100. But if I left it like that, my equation would not be in balance anymore because it was in perfect balance here, and then I added 7 and 28/100 to this side. So I have to remember, do the same thing to the other side. And you will notice that whenever I solve these on the whiteboard or on paper, I will almost always do the inverse operation on both sides in another color ink. So you can see that this equation is the exact same equation. The only difference is that I have done this to both sides. In this case, I've added 7 and 28/100. Now, these two things here are opposites. When I put them together, they make a 0. So all that's left on this side is the m, which is what I wanted. And on this side, I have the 23 and 9/10 plus 7 and 28/100. I'm going to go off to the side and do that because when I add decimals, I want to stack them and line up the decimal. Right? That is how I make sure I get it right. Now that looks weird when I've done that, huh? You want those numbers to line up. Well, this is what you have to have lined up. Now, if it looks weird and it bothers you, and it bothers me too, add a 0. You're allowed to add zeros after a decimal. Now I have a simple problem where I'm going to add 0 and 8, 2 and 9, carry that 1, and I get 31 and 18/100. I'm going to put a box around my answer and a box around all my work. But before I go, I really want to make sure this is right. So if I really want to make sure this is right, I should be able to substitute. Because if m equals 31 and 18/100, I should be able to substitute 31 and 18/100 wherever I see m. All right? So let's try it. Is 31 and 18/100 minus 7 and 28/100 equal to 23 and 9/10? Well, again, when I add or subtract decimals, I'd like to stack them one on top of another. Make sure I get it right. 8 minus 8 is 0. I can't take 2 from 1, so I got to go borrow here. 11 minus 2 is 9. That decimal comes straight down, and 30 minus 7 is 23. Now, 23.90 is the same as 23.9, so I say, yes, I did it right. Now, I got that box around my problem, my answer, I mean. I'm going to put a box around all the work for that problem as well. We call that box and box. Okay? When you're solving equations like this, it's a good thing to start doing. You find your answer simply, and you know that all the work that went into that answer is here. So if you got that answer wrong, it's going to be in something you did up here. Okay? Okay, next problem. Ready? This one's going to go quicker. My goal is to find out what y is. We call that putting it on an island by itself, or isolate the variable. Okay? The variable is that letter, and if we get it all by itself, it's isolated on an island by itself, then all that will be left is that letter, that variable, equals a number. Now, I rewrite it. It doesn't take long. Give myself a little bit of space to undo what's going on there, or get rid of a plus 4 8/800. I do that with the inverse operation, or opposite of plus is minus. Whoops. Minus. I'm saying plus and trying to write minus, and I wrote plus. So minus 4 8/800. And then I remind myself I can't do something to one side of the equal sign without doing the same exact thing to the other. So I have to make sure I subtract this side the same amount, 4 8/800. Now again, these are opposites here. Opposites attract. They fall in love. They go run away and get married. They're gone. No, they are gone though. They end up being 0 together, so they cancel each other out. That's what we say. And all that's left is y on this side. On this side, I have 14 3/10 minus 4 8/800. When I go to do that, I'm going to stack them, 14 3/10. The decimal comes straight underneath. I don't know if you guys noticed, I put the decimal as the first part of the second number. All right? I put that decimal first. I don't just write the 4, because I want to make sure that decimal is directly underneath the other decimal. And then when I do that, again, it looks kind of weird. Why? Because it only comes out to the tenths place here. It comes out to the hundredths place. So just add a 0. That also will save you so you don't bring that 8 down. I'm supposed to take that 8 away from the 30, so I need to borrow. And then I can make sure I do it right. This time I get 10 22/100. Boom. I'm done. Box around my answer, box around the problem, but let's go double check. If this is true, I should be able to substitute 10 22/100 plus 4 8/100 should equal 14 3/10. Okay, so I'm going to stack those. And add 2 and 8 is 10. Carry the 1, that's a 3. The decimal comes straight down, and 10 and 4 is 14. 14 30/100 is the same as 14 3/10. Boom, we did it right. Box around all that work. Next problem, 4a. Eventually, I want the a isolated, equals down here. Now, what does 4a mean? That means 4 times a. So I'm going to rewrite that with the a first, right? 4 times a is the same as a times 4. But this way, I'm giving myself room to do the opposite. Now, what's the inverse operation or opposite of times? Yes, divide. So the opposite of times 4 is divided by 4. Now, what do we ask myself? There's a red thing on this side, nothing on that side. Do the same thing to both sides. I can do anything to one side as long as I do it to the other, right? I can't just do it on one side. Okay? Now, if I have a number, I multiply it by 4, then divide it by 4, I'm right back where I started. Why? Because 4 divided by 4 is 1. Okay, and 1 times A is A. So A on this side and 12.64 divided by 4. Go do the math. 12.64 goes in the box. And what do you do if there's a decimal inside the box? Don't freak out. Just bring it up. That's all you got to do. Now you divide. 4 goes into 12 3 times. 3 times 4. Bring down the next number. 4 goes into 6 1 time. 1 times 4. And bring down that next number. And 4 goes into 24 6 times. Perfect fit. So there we go. I got 3.16. Put a box around my answer. And let's go substitute and double check. 4 times 3.16. Again, pretend there's no decimal and multiply. And I'm going to get 1264 here. But in order to pretend that was 316 instead of 3.16, I had to move the decimal over 2 spots, right? So that's in the problem. I got to go back 2 spots in my answer. 12.64. Boom, we got it right. We even double checked. All right, let's put a box around all that work. Sometimes your boxes don't look completely like a rectangle, huh? Yeah, running out of room there. Now, what does this mean? Backslash? You remember? Divide. And that makes sense. I have 1 subtraction, 1 addition, 1 multiplying, 1 dividing. So you can learn how to do all 4 of the major operations. I'm going to rewrite that with a division sign like this. Give myself a little bit of room to do the opposite. Now, what is the opposite or inverse operation of division? It's multiplying. So to get rid of a divided by 7, I'm going to do a multiply by 7. And then again, what? Yeah, do the same thing to the other side. Now, dividing by 7 and multiplying by 7, they cancel each other out. All that's left is x, which is what my goal was. So I didn't write my goal down first time. X equals 6.32 times 7. When I multiply, I pretend there's no decimal and pretend that's 632 times 7. 14, 1, 21, and 1 is 22. Carry the 2, and 42, and 2 is 44. Uh-oh. I'm not seeing this answer, am I? Oh, well, let's see. I had to move that over twice. So in the problem, I have to go back twice in my answer. 44 and 2400ths is my answer. Let's put a box around that, and now let's double check. If this is true, I should be able to rewrite that and substitute. 44 and 2400ths divided by 7 should equal 6.32. How do I do that? That 44 and 2400ths goes in the box, and the 7 outside, the decimal comes straight up. Now, how many times does 7 go into 42? 6 times. Bring down that next number. 7 goes into 21 3 times. I said 21 because it's close to 22. And look at that perfect fit. 6.32, 6.32, bam, we got it. All right, so this wasn't that bad. Hopefully you are taking your time, and hopefully you are trying to earn that extra credit point by using that inverse operation on both sides in another color ink. And if you keep talking to yourself like I talk to myself, you'll start remembering this faster, right? Ask those same questions. What's my goal? Okay, what do I have to get rid of? How do I do it? I use the opposite or inverse operation. If I do it to one side, I do the same thing to both sides. When I get done, can I check it? How? Substitute. All right. If that variable equals this number, I should be able to substitute that number for the variable every time I see it. Go double check your work, and then you can feel good about making sure that you did it right. All right, everybody? Don't forget the easiest 3 points. All right. Hopefully that makes it a little bit clearer and a little bit easier for you to understand.